we're just going to kind of get started on stuff today, and we'll just go until we feel like we've done enough, and then we'll stop.
Until we're crying. Here's the blood.
And, yeah, until you're crying.
Sweating blood.
Yes.
Like Jesus.
Yeah, I need lots of blood excreted. So, you're ready for just an intense day of math.
Oh, exactly. You don't need math anymore. Now we always play this. Rational?
So rational functions, this is another topic that we looked at in our Algebra 3-4 courses, so this should be at least partially familiar or review, which is nice, right? Like, you know, if it's not going to be too bad, that's always, or at least pretty familiar. It usually helps things go a little bit quicker, a little bit easier for us, which is nobody's going to complain about. So when we define a rational function, we say a rational function is of the form r of x equals p of x over q of x, where p and q are polynomials, and q is a non-zero polynomial. One of the first things we'll be tasked with is determining domains of rational functions. So again, think about a rational function just as a fraction. What's the one situation that can get you in trouble with a fraction? Dividing by zero. So your domain is essentially going to be all real numbers except for whatever makes q of x equal to 0. Maybe except for x such that q of x equals 0. Maybe we'll say x equals a. So let's just do a couple of examples here real quick. So again, we're just going to be looking for the domain. That's all we're going to be looking at. So, what do? Just take my denominator, set it equal to 0, and solve. Everybody's good with that? Sophia?
What does the line under domain say?
All real numbers. Oh, except for x equal to a such that q of a equals 0. So just everything except for the numbers that give you a 0 denominator. You can write that in words if you prefer. It doesn't have to be so symbol heavy. So in our example then, we can say our domain would be all real numbers except for 1/2, right? But we're not going to write it that way because that's not a very formal way of writing a domain. Typically we use interval notation in doing this. How would I write the interval notation of all real numbers except for 1/2? Shoo! Yep. So again, if I look at this interval, it's everything up to 1/2 and everything after 1/2, but it's not including 1/2.
True.
Let's do another example here of finding a domain. So we got these new computers, which is lovely. It's a much better machine than the previous computers that we had. The only drawback is the stylus is so short, it's very hard to write with.
Oh, you stylus?
Yeah, like it's like you got like somebody karate chopped your pencil in half, and now you just have like just a little nub that you're trying to write with.
Do you have your old stylus still?
And old
No,
ones
we had
like
to turn it in with the computer.
Oh, because I lost mine.
I lost that.
Oh, you're funny.
What?
What?
Isn't that uncomfortable though?
Right, like that.
I mean, I just don't like dragging my hand across it because I just get tired or whatever, and I just end up dragging my hand and it causes more problems because it keeps moving my spine.
Yeah, well, no.
Yeah, it just goofs it up. So I just leave it at an angle because then I can't put my hand on it and goof it up. I just want a regular length stylus. Is all I want, like one that's the same
You probably
size.
tape them.
Tape it to a pencil.
Yeah, true.
Yeah, there we go. Make it look. Well, and then it doesn't have the erase at the other end. You have to press a button to do the
You
erasing.
just untape it. I tape one on another one. Buy like another stylus, like $100.
Yeah, and then just tape it like this.
Yeah.
And then I can use it two-sided. I could have two tablets like this and I can write on both of them at the same time.
Awesome.
All right. Anyways, again, taking the denominator, setting equal to 0.
Anyway.
So this one, we'll solve by factoring. So the first thing I'll do is pull the greatest common factor of x. I notice that I'm left with then a difference of 2 squares. And then if I apply the zero product property and solve, I get the 3 solutions, 0, 2, and -2. Everybody cool with that? So when I write my domain, again, I have to go from small to big, so I have -infinity to -2, and then -2 to 0, and then 0 to 2, and then 2 to positive infinity. Everybody's okay with that? So again, we just have like a little break every time that denominator would equal to 0. No big deal. So we've talked about domains. What we're going to do now is we're going to start transitioning into graphing these rational functions. And there's several key features that we're going to want to be able to graph. The first one is the vertical asymptotes. And we find these by solving the reduced denominator equal to 0. then the second is these end behavior asymptotes. And these are a bit trickier because there's three different types or three different cases. So the first one is if the degree of the numerator is less than the degree of the denominator, then our end behavior asymptote is at y equals 0. If the degrees are equal, our end behavior asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. So it's still a horizontal line, that end behavior asymptote. The trickiest situation is the third case, where the degree of the numerator is greater than the degree of the denominator. In that case, what we need to do is we have our function r of x equals p of x divided by q of x. So we're going to do our long division to write this in the form here. And then our end behavior asymptote is the function y equals a of x. So in most cases that will be a line, but it could be a quadratic or a cubic or something else that's worse, but not in this class. Right? Probably a quadratic would be as bad as it would get. But keep in mind here, just for heads up, that if we did this same process in C, in these other two situations, you would get the correct result. So if you're never sure what to, like if you get the rules mixed up, you can always just do the long division and take whatever the quotient is, and that'll tell you your asymptote. Everybody's okay with that? Like if you take x and try to divide by x squared, x squared goes in 0 times. So just y equals 0, because the degree is less than the other one. Okay, next up is the zeros for the function, or you could call them the X-Intercepts. Use those two terms interchangeably. How do you find those? Is we set reduced numerator equal to 0 and solve. And we have y-intercepts. And that we just plug well, I'd just say it's f of, let's say it's 0 comma r of 0. Probably the easiest way to write it, right? Just putting 0 in for x, like we've done before. So let's do some examples. So here's our function. First thing I'd want to do is to see if I could do any reducing. So I'm going to factor this completely. And I notice that there's no reducing that can be done because none of the factors in the numerator and denominator are identical. Everybody's good with that? So I'll find my vertical asymptotes then by just taking the denominator and setting it equal to 0. And then solving. So my vertical asymptotes are at 2 and negative 2. Then I'll find my x-intercepts, or my zeros, by taking the numerator and setting it equal to 0. And when I write my x-intercepts, I usually write it as the point 1, 0, rather than x equals 1, just because I don't want it to get confused with my vertical asymptote or something. You know what I mean? Because that's easy to do when you just have a bunch of like x equals pieces laying around. My y-intercept is just plugging 0 in for y, or I'm sorry, in for x. So that gives me the 0 comma, and then 1/4. I'm just going to write it as 0.25 since I'm going to graph this. It's a little bit more natural to place a decimal than it is a fraction. Although 1/4, not that big of a deal. Easy to approximate where that is, but if it was like several fractions that we had to graph, just give me decimals, man. And then we want to look at those asymptote and behaviors. The degree of the numerator is 1, because I just have an x to the first. The degree of the denominator is 2, because I have an x squared. So that tells me that I have my asymptote and behaviors, this horizontal line along the x-axis, y equals 0.
How do you know that?
Because the degree of the numerator is less than the degree of the denominator. That was one of the rules from before. Cool so far? So
I have a question. For the y-intercept, so is it just like, is it just like the x over y?
I'm just plugging 0 in for x.
Oh, okay.
Is all I did there. I just didn't write the squared on 0 because 0 squared is still 0.
Yeah.
Is that cool?
Yeah.
Yeah, no problem. So I have my xy axis. -1 positive, -2 positive, +3, 1, 2, 3, 2, 3. So I'm going to draw in my vertical asymptotes here. And my horizontal asymptote slash and behavior. Everybody okay with that? Those are supposed to be dashed lines, but I'm not very neat. So Yeah, Josh.
Sorry, I'm still a little confused on how to find asymptote and behavior.
So I followed these rules here. So in our case, the degree of the numerator is 1 and the degree of the denominator is 2. So we fall into category A, which just tells me it's y equals 0.
Oh, okay.
So that's all I did. Is that cool?
Yeah.
So we have. Okay. So I have 1, 0. Oops. I meant 1, 0. And then 0 and 0.25. Now my question here becomes, which direction am I following the asymptotes, right? Like which side of the asymptote would my arrows be? Is that okay? It's kind of what I need to figure out. After I know that, I can kind of connect everything together. Does that sound okay? So what I'm going to be curious about is whether the y-coordinate is positive or negative when I'm very close to this side of -2 and then very close to that side of -2. So I'm just going to use my graphing calculator to kind of deal with that. Okay. So I'm just going to go to the y equals menu and I'm going to type in my function. I'm just going to delete out these other things that were in there. So I have, what was it, x minus 1 over x squared minus 4, right? Exit out of there now. And what I'm going to do is I'm going to use the vars menu, over to the y vars, and then to the function option, and retrieve the place where I typed in my function at. For me, that was y1. So I'm going to pick something on this side of -2. So maybe -2.1. And I'm getting a negative number, so I'm somewhere down here. Everybody okay with that? And then I'm going to continue. I'm just going to check, okay, if I get a little bit closer, that should be getting even smaller. And it does, so I'm pretty positive that I have the right end behavior going on there. So I know that this piece, oops, it's got to be doing like this, right? Because it's stuck underneath that horizontal asymptote, and it's got to be going that way down. Pretty cool. I'm now going to look at the other side of -2. We do -1.9. And there I'm getting a positive number, but just to be sure, let's get a little bit closer, maybe do -1.99. Even bigger, so I'm pretty content that that's happening. So I know I'm going to be doing like this. Going through my y-intercept, my x-intercept there. And then I have to see what's going on at this side of 2. So I'm going to do the same little tricks. So I'm going to use 1.9. And there I'm getting a negative number, just to make sure. Let's get a little bit closer. Make sure it gets more negative, which it does. So I'm pretty convinced that this thing is now going to go like. And then the last thing I need to do is see what's going on this side of positive 2. Yeah. So to get the y1, you press bars and go for the y bars because you want a y variable. And then you want to pick from the function menu, and then whatever place you typed your function into, pick that corresponding y value. Whether it's y1 or y2 or y3 or whatever. Did you find it?
Once I go into the y bars, I enter in the function, and I have a list like 1 through 9 of like y1, y2, like that. And then I hit enter on the y1. That's what I put my function on.
Okay.
And
then you
it
just
goes to
type
y
the-
equals 3.
Yeah, that's what it's supposed to.
Right.
Oh, and then it goes to the y equals screen.
Yeah.
That's because you're on the y equals screen when you press the bars menu. You have to be on the home screen when you press the bars menu. Because it's going to put that y1 wherever your cursor was last.
Oh, okay. I see.
Is that okay?
Yeah. Working.
Everybody happy with what we did there? Again, we didn't generate any kind of XY table. I didn't want to get 3 points on either side of each asymptote, which is probably what we did in your Algebra 3-4 class. This is a little bit cleaner because what we're actually looking at is we're evaluating the limits. So just to show you what we found using limit notation, which it seems like many of us didn't know what that meant. So like if we're talking about this arrow pointing down, that's the limit. As x approaches the value of -2, and since we're talking about the left side of it, we'd say from the left, so I put a little negative sign in the exponent there, of f of x would be equal to -infinity because the arrow's pointing down. Or if we said we're talking about this arrow, here we would say the limit as x approaches positive infinity of f of x is equal to 0. Right? The arrow is moving to the left, that's, to negative infinity. Right? The arrow is moving towards negative infinity in the x direction. And the arrow is moving to 0 in the y direction. Let's do one more just to kind of reiterate this, because this looked like something that we were supposed to read about in the last chapter, and I don't think everybody caught all of this. So.
Do we have to do this for every point on homework?
So you have to worry about this for the asymptotes. And I'm just explaining to you the limit notation again, because that was something that was supposed to be hit on last chapter and looking at the tests. Briefly that I did, this was a place where a lot of people didn't have much to write there, or weren't sure what to write there. So I just wanted to go over the notation again, because it's mostly just a notation. All it's doing is describing with symbols what we're seeing in our picture. So what we're seeing in this picture is as the graph moves towards the x-coordinate of -2, the arrow is pointing up, right? Everybody agree with that's what you see when you look at that blue circle in our picture?
Yeah.
Okay. So the way we write that is we'd say the limit as x approaches 2 from the right, so we're going to use a positive or a little plus sign in the exponent to show which direction we're approaching 2 from, because the limit is different depending on whether you approach from the left or the right, because one arrow's going down and one arrow's going up, right? and our function's name was f of x. And in this case, since the arrow is pointing up, it's going to positive infinity.
Why is it positive 2 again?
Oh, that's supposed to be negative 2, excuse me.
Oh.
Thank you. Very good. It's good we're paying attention, right? So again, all we're doing is describing if we're going towards like what the arrow is doing, right? The arrow is going towards this x value. What is the y value doing? Amanda.
So if you're approaching like the asymptote from the right, then it will be like a plus sign. Okay.
So again, you think about it as from what direction you're coming. So the right is where the positive things live. So if you're coming from the positive things, you're coming from the right. The left is where the negative things live. If you're coming from the left side, it's a negative.
Thank you.
You're welcome. So it's not the direction of the arrow,
Okay.
of like which way you're
Yeah.
moving. It's just which side. Does that feel okay? Feel a bit better about the notation for the limits. We can do those. We can do some more again when we look at another example. Let's do another. Let's say we have the function f of x equals x squared minus 4x plus 5 over x plus 2. So the first thing that I would want to do is I'm going to see if I can factor this at all, to see if there's any reducing that can happen. So the denominator is obviously already factored, right? You can't do anything more with the x plus 2. The numerator, though, maybe that looks like something I could factor. To factor a quadratic like that, we have to find the two numbers that multiply to give me 5 and add to give me negative 4. Since the leading coefficient is 1, I just care about those two numbers. Is there anything that multiplies to give me a positive 5 and adds to give me a negative 4? No, right? So that thing doesn't, well, I should say there's no integers that do that, right? There are numbers that do that, but they're either going to be irrational or imaginary, which in terms of factoring doesn't really matter to me. Everybody's good with that? Okay? So this is as reduced as it can happen. Everybody agree? So to find my vertical asymptotes, I just take the denominator and set it equal to 0. To find my zeros or x-intercepts, then I'm going to take the numerator and set it equal to 0. If that doesn't factor, though, how am I going to solve that? Do the quadratic formula, right? That's just a quadratic that's equal to 0. You guys agree? So negative of negative 4 plus square root of negative 4 squared minus 4 times 1 times 5 over 2 times 1. Sorry, I just need to change my mode real quick. Well, actually, for graphing purposes, it doesn't really matter. Oh boy. x equals 1 plus or minus 2 plus or minus so again, since this is imaginary, imaginaries don't go anywhere on a graph, right? So I have no x-intercepts is basically all that's telling me. Is everybody okay with that?
So if your calculator says error, pretty much you would have.
Well, it's the type of error,
Oh, okay.
right? It's a non-real.
Okay.
And then the second, I don't know why I was getting an error the second time. I just didn't feel like retyping it in because it would have worked then the second time after I changed the mode.
Okay.
But I think it was probably because I was trying to take something from an old mode and bring it to a new mode that just didn't like what I was doing. And I tried to copy it, so I just said, fine, forget you. I'm just gonna do it in my head because it wasn't that bad. The y-intercepts, we're just plugging 0 in for x, right? So that gives me 0 and 5 over 2, or 2.5. So everybody follow that? Again, I just did that in my head. That shouldn't be too bad, but if you don't follow what I did, I can certainly explain it a little bit more, and that's okay. And then my asymptote and behavior, the degree of the numerator is 2, the degree of the denominator is 1, so that tells me I have to do that long division, right? And it actually, if I look at this particular problem, I don't have to do the polynomial long division, since my denominator is degree 1 with leading coefficient 1, I can do the synthetic division on this, which is what I would do because it's way faster and less to write down and all that jazz. So that's the way that I'm going to do it. You could do long division still, that would be okay. It wouldn't be wrong, but I wouldn't do it that way. So what I get is x minus 6 plus 17 over x plus 2. Everybody's okay with how I translated the results of my synthetic division to that answer? Now the piece that I care about is this, the quotient. That's my asymptote. Everybody okay so far? Yes, Sophia? Certainly. Okay. So I've done everything I need to draw my graph, or at least to place my asymptotes, and then we'll figure out what my end behaviors are actually doing there. Oops. Red graph. I've got my vertical asymptote here at -2. And then I'm going to graph this line, my diagonal line, by just using the x and y intercepts for it. So one point on this line would be 6, 0, and another point would be 0, -6, right? Everybody's okay with that? Oops. far so good. And then I know that I have my y-intercept up here at 2, 0, 2.5. Okay. I'm going to go in and type this into my y spot. So x squared minus 4x plus 5, and then x plus 2. Now we'll exit back out to the main menu. Go vars, y vars, function y1. And I'm going to look at what's happening on the left side of negative 2. That's really negative. And then we'll get a little bit closer to negative 2. Uh-oh. Well, even more negative. So I'm convinced the arrow should be pointing down on the left side of negative 2. So that means if I follow this asymptote, it should be looking like that. Are you okay with that? Yep. A little wacky, but that's all right. A little wacky. Little, though. Then we'll look on the other side, so negative 1.9 is really positive. Let's get a little closer, though, just to double check. So negative 1.99 is even bigger. So we're going to be why is this not? I want to move my stupid thing. Let me look at this again real quick. This is strange. Let me just look at something real quick. Oh, sure. Okay. So I have one other piece of information that's going to be pretty important to me before I try to draw this next piece of the graph. And it's remembering that I have no x-intercepts. So when I draw this next piece, I have to make sure that I don't cross the x-axis. So I have this starting from up here, and it's going to go like that. Is that okay with everybody? Let's write some more limits here, just for practice. So this one is the limit as x approaches negative 2 from the right of f of x, and that arrow is pointing up, so it's towards positive infinity. And you don't have to put a plus sign there on positive infinity. I always put it on there because I write negative infinity. It just keeps me from forgetting signs or whatever. What about this one? Well, how would I describe that limit? what value of x is that arrow pointing towards? Positive infinity, right? Because the arrow's pointing to the right. It's not bounded by an asymptote of f of x. And then what y coordinate is that arrow pointing towards? Positive infinity also. Good. Is that feeling better? Let's do, what do you guys think? We still got a bunch of time, right? You want to do some more examples? You ready to move on to another topic? Yeah, of course. Do you want to see something that's like in between these two examples or something that's harder? Maybe I shouldn't say hard, but kind of unusual. I don't know why all of a sudden I lost the touch capacity for this. Let's say we have x cubed plus 3x squared minus x minus 3 all over x. Okay, the first thing I would do is try to check to see if I can reduce anything. Here, since the denominator is a monomial and the numerator contains no greatest common factor, I know there's obviously no reducing that I can do. Is everybody clear on that? Could I still factor the numerator? Sure. But I don't need to do that in order to decide that there's no reducing that can happen. Is that okay? So I'm not going to worry about that right now. I'll take care of it later. So the vertical asymptote I just find by setting the denominator equal to 0. Well, there's nothing to solve there, just x equals 0. Sure, no big deal.
Yeah.
The x-intercept is going to be taking that numerator and setting it equal to 0 and solving. Now I notice that this is something that I can factor by grouping. Since there's 4 terms, and I notice that if I group it and take a greatest common factor from each of the 2 groups, the remaining factors will be the same. So the fact that each of them contain a factor of x plus 3 allows me to take that greatest common factor out. And then I notice that I still have a difference of 2 squares there, that x squared minus 2 can factor as well. And then once again, I'm going to write these as ordered pairs just to not confuse myself, because I don't want them to actually accidentally start thinking those are asymptotes when I go to draw my graph. I've done it before, that's why I do
So
it.
y-intercepts or the x-intercepts become the points?
So x-intercepts become points, yes. Same thing with y-intercept is always a point. Well, I should say is always a point, because what's going to happen in this case?
That's okay. You will.
There isn't an y-intercept. Why not? What happens if I plug 0 in? The denominator is 0. It's undefined. Oh! I know. last thing I need to worry about is this asymptote and behavior. So again, I notice that the degree of the numerator is greater than the degree of the denominator, so I know I have to do the long division here. And I'm not my divisor isn't monic because there's no zero term or no constant term. But really there is, right? What is the constant term there? 0, right? So I can still do it as synthetic division. So this says that f of x is equal to x squared plus 3x minus 1 plus negative 3 over x. Everybody's okay there? Oh, yes, sir.
Do you ever have to do long division? Like, can you always just do synthetic?
If this was like 2x minus 3 in the denominator, I would do long division there. Or if the denominator was like x squared plus 1, you'd have to do long division there. So you definitely can run into those situations. I would try to make those not every time that you have to do this, do you have to do that? Because it's just kind of a pain in the tuchus.
Why is that equal? Wouldn't that be? Or
So the alternative way to think about it,
I'm just curious how you got minus 1 plus negative 3 over x. That would have wrote it.
so again, this is the remainder, constant x coefficient, x squared coefficient.
Okay. So it's different for these problems?
No, it's the same as it was before.
Oh, yeah. Oh, yeah. Yeah.
So the other way you could think about this is since the denominator is a monomial, you could also do this. Which is still the same thing that we got there. So you can think about it that way as well. That's also a perfectly reasonable thing to do. But that only works because the denominator is a monomial. If the denominator's a polynomial, you can't break it up like that. Well, you have to take the entire denominator and make each one of those fractions the entire denominator, and that defeats the purpose of getting a remainder. But either way of doing it is fine. So the big takeaway, though, is there's our asymptote, which is parabola? What?
Hold up, I got the original.
That's okay, no. I can have that. Yeah. Thank you. We needed that.
So that means the essence.
So let's put this together.
Did that fast. Why you have that bookmarked?
Well, he's a Boy Scout. He's always wanted to interfere. You never know when you might have to make a weird sound effect.
Yeah, mine.
Let's see. So there's my vertical asymptote. To graph this parabola, what do I have to have?
X-intercept, Y-intercept,
You need the vertex,
vertex.
right? How do I find the vertex of a parabola?
I don't know what a parabola is. You graph it.
So the vertex, if your quadratic is written in standard form, as this one is, can be found by doing negative b over 2a, and then f of negative b over 2a.
You have to do this a lot.
So in our case, that's going to be negative 1.5. And then if I plug that in, I get about negative 3.25. And then I'm going to also be interested in maybe getting the X-Intercepts for this. That would probably be enough to get a decent picture. Pedro?
Can I go to the bathroom?
Of course. So how do I find the X-Intercepts for this quadratic?
Plug. Yeah. Plug it in 0.
Make it equal to 0 and then solve, right?
Mr. Cole, do you think we're gonna have many of these in the homework?
Probably not a lot that are this difficult. You'll probably see at least one. So how do I solve that? It's not factorable. So I would want to use the quadratic formula. So that would be negative 3 plus or minus 9 plus 4 over 2. So again, we're graphing this, so let's type that into our calculator. Because I don't know about you guys, but I don't really know where I would put negative 13 or negative 3 plus square root of 13 over 2 at. So one of the values is negative is 0.3. And then I'll just change that to a subtraction. The other is negative 3.3. Okay, so let's see, negative 1.5 and negative 3 1/4. Negative 0.3 and then negative 3.3. So there's my other asymptote, or my end behavior asymptote. So what I need to know now is what is my graph doing at this asymptote of x equals 0. So I'll go and do that the same way we did before. X cubed plus 3x squared minus x minus 3 all over x. Is that right? Yeah. That is definitely not a good enough, or you type in the wrong function there, that's not going to work for us. So go back out to the main menu, y-var's function, y1, and we're looking at the left-hand side of 0, so maybe negative 0.1. That's positive, and just to make sure, let's get a little closer, so we'll do negative 0.01.
You just stored the equation.
I'm typed the equation into the y1 spot, so I can do this y1 of whatever as a function. Yeah. So if you type that into the y equals menu, you can then use it like a stored function, and you just do like function notation on it, which is pretty rad.
That's
All right, so this tells me that we should be, this end should be going like that. We have zeros at 1, -1, and 3. So we need to do that, and then we should be following that other asymptote. Everybody's okay there? Then we need to figure out what it's doing on the right side of 0. So we'll start with positive 0.1. That's -30. And just to make sure, let's do 0.01 also. Even more negative, I'm pretty convinced. This is going to be coming in here, and then up through my X-intercept. Through my X-intercept, and then it's going to go on following my parabola. Right, it's still got to follow this asymptote here. So I'm just going to extend that out a little bit. Does that make sense to you guys? And again, you can always look at the graph on your calculator to kind of give you some reinforcement on this, but I'd like you to try to be able to do this without graphing it on your calculator, just looking at the picture, because it is a skill that we should be able to do with, without having to look at the graph. Like this is back in my day, when we didn't have a graphing calculator, this is how you would do it. Now it's easier to evaluate these things, to find the limits with the graphing calculator, because you can do the store of the function and not have to type it in over and over and over again, which is a hassle. But
if we ever were in trouble on a test, would you be able to tell if we just drew what was on a graphing calculator?
I mean, I can ask the questions in such a way that your graphing calculator won't necessarily help you.
Are you going to do that?
I don't know. That's the test. I mean, I feel more inclined to do it now after these questions that you just asked me. And that feels like probably enough for today. Don't you guys feel good?
Yes.
Yeah. All right, let's look at this here. 400. So you should be able to do.
At least one.
Well, it looks like 1 through 24 are all doable. Yeah.
How many problems are there?
Total in this chapter, 57. Not that bad. It's not a 1-to-1.
Right.